by Math 2 Enhanced. This is page 25 of our packet, and we're doing some projectile motion. So we have a baseball that's been batted up straight up in the air with an initial velocity of 112 feet per second from a height of 3 feet. And the height of the ball in t seconds is given by this equation that we're going to be using. You can forget about the hints here. You can solve these problems in any way that you would like. So first of all, let's take a look at A. A says, what is the height at t equals 1.25 seconds? So I'm not really being asked to solve anything. Instead, I'd like to find the height, that's my h, at the time of 1.25 seconds. I'd like to substitute in then for my t's 1.25. So I'm going to do negative 16 times 1.25 squared plus 112 times 1.25 plus 3. So this is very much a calculator active activity. You do need to make sure you do the 1.25 squared first, then multiply by a negative 16. Add to that 112 times 1.25 plus 3, and we should be getting 118 feet. So at 1.25 seconds, my baseball is 118 feet in the air. If you can't get that from your calculator, come see me. I'm sure it's just the way it's being input. So part B says, when will the ball have a height of 3 feet other than when it's first batted? So you have to remember this object, this baseball, it was hit at time 0 at a height of 3. At some point it reaches its maximum height at a certain time and a certain height that gets to its max height, and then it falls back to the earth. And when it falls back to the earth, it'll fall back at a certain time, it'll hit the ground and be a height of 0. So it's asking me for what is this other time right here that it's also at a height of 3. I'm looking for that time where my ball is also at a height of 3. So I want to set my height equal to 3, and I want to find the other time. So negative 3 equals negative t squared plus 112t plus 3. I'm going to subtract 3 from both sides, because remember, I can't do anything until it's equal to 0. And I get 0 equals negative 16t squared plus 112t. Now you need to solve this. And I think a smart way to solve this is to do GCF factoring, because both terms have a t, and both terms actually are divisible by 16. 112 divided by 16 is 7, but you can check those sorts of things on your calculator. If you're not sure off the top of your head, you can divide 112 by 2, divide it by 4, divide it by 8, but you'll find that the GCF of 16 and 112 is 16. So I'm going to factor out a negative 16t. That's my GCF. You don't have to take out the negative for it to work, but I like to do that. When I can take out a negative for my leading term, I do. And when I divide my first term by my GCF of negative 16t, I have a t left over. So I've got a t in my parentheses. And when I divide my 112 by my negative 16t, I'm going to have a negative 7 left over, because the t's completely cancel. So now that I have this factored, I know by the zero product property that one of my two factors is, sorry, it's a t minus 7. It's all, t minus 7 equals 0. So I can divide both sides by negative 16, and I get that t equals 0. So I knew that one. Actually, I probably shouldn't put a box around it. I knew that one already. Also, at 7 seconds is the other time that my ball is also at a height of 3. And so that was B. So let's take a look at C. It says, when will the ball have a height of 163 feet? So for part C, I want to know when it's going to have a height of 163 feet. So I'm going to let h be 163 equals negative 16t squared plus 112t plus 3. Again, I can't really get started until I subtract my 163 from both sides, and I get 0 equals negative 16t squared plus 112 t, and then this is now minus 160. So in this problem, I will tell you factoring actually does work here. You have a GCF of negative 16, and then it's totally factorable. But I think more of us are probably going to use the quadratic formula. It's much less desirable. The factoring would be much quicker. But we're going to go ahead. I'm going to use the quadratic formula in the video just because I think that's what a lot of you guys would do. So I know my A is 116, my B is 112, and my C is negative 160. Whew, those are some big numbers. Like I said, if I took out my GCF of negative 16, everything would get a lot smaller. So here we go. My T, or my X, my time, my variable is equal to negative B, negative 112, plus or minus the square root of B squared, which is 112 squared, minus 4 times A times C, all over 2 times A, 2 times negative 16. So now my T equals negative 112 plus or minus, and I'm going to grab out my calculator because I need to do 112 squared, and 112 squared looks like it is 12,544. Now, this is a negative times a negative times a negative, so I know the number I get here is also going to be a negative. Let's do 4 times 16 times my 160, and I'm getting 10,240 all over negative 32. So now I'm going to simplify some more. So I've got negative 112 plus or minus the square root of, now I'm going to do 12,544 minus my 10,240. I'm getting 2,304. And you're going to find that if you do the square root of that, you are going to find that it is a perfect square and it's equal to 48. So this is really negative 112 plus or minus 48 over negative 32. Don't cancel anything unless you're going to cancel it from all three terms. But this means I have two answers for t. One answer is negative 112 plus 48 over negative 32. And the other answer is negative 112 minus 48 all over negative 32. So let's grab out our calculators, and I'm going to do negative 112 using the negative button on my calculator, plus 48, and hit equals. Careful about the equals. And when you divide that by a negative 32, you find that you get 2. So 2 seconds is one of my answers. And when I do negative 112 minus 48 and hit equals, and then divide by a negative 32, I get an answer of 5 seconds. Again, if you're not getting the right answer on your calculator, just come see me. It's probably a common thing. Both of these answers work, and let me change the color on my pen, and let's go back up towards the top of the page. So that means that wherever this height is, and I'm just estimating, let's just say that it's right here. This is 163 feet, and again, I'm just messing around with this. I have no idea if that's a good place to put it. But that happens at 2 seconds, and it also happens at 5 seconds. So that's what that's implying. So once on the way up, it's 163 feet, and once on the way down, it's also at 163 feet in the air. So let's do D. D says, when is it at 220 feet? So I'm going to set my height to 220 equals negative 16t squared plus 112t plus 3. And I'm going to subtract the 220 over, and I get negative 16t squared plus 112 minus, then I think that is 217. Oh, and I forgot a t right here. I'm so sorry. It's very messy right there. Maybe we should 112t, and I believe you get minus 217. So this, by the way, does not factor. So I am going to use the quadratic formula again with my A is negative 16, my B is 112, and my C is negative 217. And I go to set up my quadratic formula, and my t is equal to my negative b plus or minus my b squared, which I happen to know is 12,544 from my last problem, minus 4 times a times c all over 2 times a. So now I'm going to clean up underneath that radical a little bit. I have a negative 112 plus minus my 12,544. Now this is a negative times a negative times a negative, so I know my answer is going to be negative, but I don't really know what it is. Let me grab my calculator. 4 times 16 times 217. Looks like I'm getting 13,888. At this point, I can really stop. And the reason I can stop is because I know the number underneath my radical is negative. In fact, if I do the math under my radical, 12,544 minus 13,888, I believe is negative 1,344. That is going to have an I in the answer. The moment I take the square root of that negative, I'm going to get an I on the outside. So I'm going to get an imaginary answer, a complex answer. That's a sign to stop, because there's never a time my baseball is at a height of 220. There is never a time when the baseball is at 220 feet in the air. And I know this because I'm getting a complex imaginary, sorry, I'm abbreviating if that's okay, answer. So the moment I see that underneath my radical is going to give me an I answer, I'm going to stop, because that means that time doesn't really exist. So again, I don't really know, because I don't know my max yet, but somewhere up here is 220 feet. And my ball just doesn't get to that height. It just never is that height. And that's how I know, is because I got the imaginary answer. So now question D says, question E says, when will the ball's height be maximum? And F says, what is the maximum height? These guys go together, but I'm going to have to move my screen, so you probably won't be able to see them anymore. So let's talk about E and F. So E and F go together. It really wants the vertex. So it's asking me to find my, E wants to know when it's going to be at a maximum. So that's my time that occurs. And F is asking for what is the max height. So that's actually looking for my Y value. And this is looking for my T, or my X value of my vertex. So since this is in standard form, this is my equation. My h of t equals negative 16 t squared plus 112 t plus 3. I want to find my vertex. That is the answer to this question. That's going to be the time I'm at my max height. So to do that, I'm going to use the fact that my x-coordinate, or my t-coordinate, is going to be my negative b over 2a. For this problem, that's negative 112 over 2 times negative 16. So for this problem, negative 112 divided by negative 32, I believe gives me 3.5 seconds. So if I'm looking at this, at 3.5 seconds, that's a terrible parabola. Sorry, my Apple Pencil's kind of hard to work with. But this is my max height, and it occurs at 3.5 seconds. So I know that my ball reaches its max height at 3.5 seconds. So I need to find the height at that time. So I'm going to substitute my time back in to find my height at 3.5 seconds. So negative 16 times 3.5 squared plus 112 times 3.5 plus 3. And again, I'm going to put that all into my calculator carefully. And you should get approximately 199, not 119. 199 feet. So I'm at 199 feet at 3.5 seconds, and that's my max height. and the time when it occurs. So the next question asks for what time it hits the ground. So what time it hits the ground is going to be a problem where I set my height equal to 0. So 0 equals my equation, negative 16t squared plus 112t plus 3. If you look over here, I'm looking for this right here. I'm looking for what time my height is 0. So this problem, I would use the quadratic formula for. So my A is negative 16, my B is 112, and my C is 3. So my time would be negative B, or negative 112, plus or minus the square root of, and now I have my 112 squared minus 4 times negative 16 times 3, all over 2 times negative 16. So my T is equal to negative 112 plus minus the square root of, and I believe 112 squared was 12,544, and then a negative 4 times a negative 16 would be a positive 64 times 3, I believe is 192, and it would be a positive 192 all over negative 32. So this is becoming negative 112, plus minus, sorry, writing too fast, plus minus, underneath that radical, I'm not sure of the number, so let's grab my calculator. 112,544 plus 192, looks like it's 12,736 all over negative 32. So I want to put that into my calculator. So one of my answers is going to be negative 112 plus that square root, 12,736, all over negative 32. And the other answer is going to be when I subtract it, negative 112 minus this square root, all over negative 32. And I put those into my calculator. I have the answers sitting here to the side. So when you put in your negative 112 plus your square root and divide by your negative 32, I believe you should be getting approximately negative 0.02 seconds. And when you do your negative 112 minus your square root divided by negative 32, I believe you should be getting 7.02 seconds. And so this hits the ground at 7.02 seconds. Going back over here to the left side. And this negative one, this is this one over here. But this is like going back into time. So in a realistic problem or a real life problem, the negative answer doesn't make any sense. So I cross it out. The very last question, oh, this was G. When will it hit the ground? The very last question, H, wants to know my domain and range. Now, it's a little different than what you and I have been doing in class. Normally, the domain for a quadratic equation would be all real numbers. It would be negative infinity to infinity. But this is a real life problem where my domain, remember my domain is my x values. So in this case, it's my time. What works for my time? Well, my time ranges from time of 0 to when it hits the ground at 7.02 seconds. And my range for this real life problem is really just the heights. So my heights of my baseball ranges from when it hits the ground, and that's its lowest height, to 199 feet. That's its highest height. Oh, and I'm sorry, I'm trying to explain, and those all need brackets, not parentheses, because it actually, the 0 seconds is when it starts, 7.02 seconds is exactly when it ends, it's included, and my height of 0, it lands on the ground, so it is actually 0 feet, and my maximum is 199, so it is actually 199 feet. So I hope that this was helpful for this page 25. Thank you.